Hi 111. In this video I'd like to do an example from section 2.6. I'm going to be doing number 14 from that section of problems. It's on page 115 if you'd like to have your own to look at, but I have pulled up our digital copy of our textbook here so that we can also read the problem together. Okay, so again, these are in section 2.6, which is all about using functions to model things, right? To model real situations like lengths and distances and areas and perimeters and things like that. So that's going to be a situation that we have going on here. So let's just read number 14. So we have a wire of length x, and we're going to bend it into the shape of a square. Okay, so let's first draw a picture. Remember, I told you that the first thing you should always do with these problems from section 2.6 is to draw a picture. And I know this is kind of silly, but let's just draw the wire, right? So I first of all draw my wire. Okay, here's my wire, and I know that its length is x. Length is x. Okay, and we don't know what the units are or anything like that, so let's just ignore that for right now. Maybe it won't even matter. What we'd like to do is take this wire, and we're not going to cut it or do anything, but we're just going to bend it, and we're going to bend it into the shape of a square. Okay, so I'm going to take this wire and we're just going to bend it. So let's say I started bending it straight. I'm going to bend it straight down, over, up, and across, right? And of course the two little pieces would connect right over here, like we would make those connect right here. Okay, so now what does that mean? Well, let's see. The first question is that in part A we want to express the perimeter of the square as a function of x. Okay, well, let's ignore the part about the function of x for a second. Let's just think about the perimeter of the square. What would be the perimeter of this square? Well, let's think about our original wire here. The original wire was a length of x, right? I didn't do any cutting or anything to make this new square. I just bent the wire around. So isn't the length of the wire all the way around still x, right? If I unfolded this square and laid it all straight out, the length of the wire would still be x. Well, the length of the wire going all the way around the square, right? That is the definition of the perimeter of this square, right? So here the perimeter of the square is actually equal to the length of the wire. And of course that equals x. Okay, and again this is part A. Okay, so what we found is that the perimeter of the square is the same as the length of the wire, and that we called x, remember? So now let's address this whole function issue, right? I want to write this perimeter as a function of x. That means I want to use function notation, right? I want to say, what is the perimeter of the square if I know x, right? I want to write a function that outputs perimeter when I input x, right? Notice this is function notation, and it would say that it takes in a value of x, right? And the value of x here would be the length of the wire, and it would output what? Well, it would output perimeter because I called it p right here, right? So that would be an output value here, right? You could even call this, if you wanted to be specific, you could say p equals p of x, right? Kind of like we did in class with the distance function. We called it d equals d of x, right? So here it's inputting a length and it's outputting a perimeter. Okay, and how do we define this function? What does it do as a rule to calculate the perimeter? Well, remember, if you tell it that the length of the wire is x, it's going to tell you that the perimeter is exactly the same thing, right? So here is that function notation that we can make use of now, where it says the perimeter is a function of x, right? Perimeter as a function of x, and the rule says if x is your input length, right? Well, then the rule says that the perimeter is the same thing. The perimeter is the length of the wire, which is x. Okay, so this is the answer for part A right here. This is our rule, our function as a perimeter as a function of x. Okay, but now let's try part B, because in part B it now says express the area of the square as a function of x. All right, so let's see. I'm going to erase this part down here so I don't have to redraw our square and everything. So you can remember that you can, if you didn't catch any of that, you can rewind. I know that's an archaic term, right? Because we are now all digital. But remember, you can always just back up the video and sketch down anything that we already wrote. So let's handle part B. Now we'd like to write the area of the square as a function of x. And again, we're thinking about this as a function of x, meaning we want to use that function notation where x is going to be our input, right? Okay, so how would we think about area of a square? Area of a square. Well, area of a square is sort of similar to finding the area of a rectangle, right? Because a square is just a special rectangle. And remember what we do is we take the product of the sides, right? So we do length times width here. That's just in general the area of a square. Well, that would require that we actually know what the sides are, right? We have to know what the length and what the width are. So let's see if we can figure out what those are. Remember that we talked about how the length of this wire is x, and we just bent it around, which means the perimeter is still x. The distance all the way around is x, right? Well, then what would that tell us about the sides of the square here? What would it tell us about this side right here? Remember, this is a square, right? So that means that all of these sides are the same length. Okay, and pretend that I'm a fantastic artist and it looks exactly like that. All the sides are the same length, but they all have to add up to x. Yeah, so if there's 4 of them and they're all the same and they have to add up to x, then that means that one single side has to be what? 1/4 x, right? Or if you want to instead write it as x over 4, right? Okay, think about that for a second. If you do x over 4 plus x over 4 plus x over 4 plus x over 4, which is adding up the 4 sides, you're going to get x. Okay, and again, because it's a square, that means all the sides are the same. So now when I go to write here the area of the square, when I say length times width, that just means I do what? One side is x over 4. Another side here, the length and the width are both the same. Another side is x over 4. And this represents the area of a square where what? X is the length of the wire you use to make the square, right? Because this says length, one side, times width. That's another side. And of course, we could simplify this a little bit. I could write this as x squared over 16. Okay, but notice that this is a rule, right? This is a way to calculate it. And it's saying that you can find the area, right? This calculates the area where you just know what x is, right? And that's exactly what we are doing here, right? We want to write area as a function of x. Okay, so to write it as a function, let's say the output's going to be area. And let's use function notation. Let's call it a of x, right? Notice this function notation right here says the input is length and the output is area. Okay, and that's what we wanted our function to do. Area as a function of x, area as a function of length, right? The input is length here, output is area. And I just write it using the rule I just calculated, right? Because that says if you know what the length is, what x is, the area is going to be x squared over 16. Okay, and in this one we're not actually asked about anything in terms of like domain or maximizing or minimizing or any of that stuff. We just wanted to practice writing these functions for right now. We did an example in class together of finding the domain of these things, and we're going to do another example to work with problem number, let's see if I can get to the next page. When we meet in our next class, we're going to work on an example for problem number 25 right here, which is actually one of your assigned problems for this section. So we'll do an activity for that right there. Okay, that's it for section 2.6. The video for 3.1 is next up.